Okay, so I'm continuing my review for exam 1. It's very important, module 3. It's almost half of the worth of the exam, okay? So I highly recommend that you do all of these practice problems here in the textbook suggested exercises. We're going to go ahead and talk about several of them. If you have any questions, you want me to talk further about one of the ones that I don't get to today in this video, please post that in the discussion board under Module 5 in Blackboard. We're also in this video going to do a few problems for Module 4, and here are the recommended exercises for that. Alright, so let's go ahead and get right into it. So say we have 3 books that are picked at random from a shelf containing 5 novels, 3 poems, and 1 dictionary. Okay, so the shelf contains 9 books, right? What's the probability that the dictionary is selected? Alright, so start with this. What's the probability that the dictionary is selected? Let's get my pen to work. Okay. Okay, so let's start with the probability that the dictionary is selected. So, in this type of problem, we're going to need to think about all the different ways that 3 books could have been selected. All right. So, we have selection here. Looks like 9 books are just sitting on the shelf, and they go and pick up 3. So you're not going to be picking up one, putting it back, picking up another, putting it back, right? This is selection without replacement, right? So because of that, in the denominator, you have 9 total books, and you're choosing 3, right? So this is the number of different ways that you could choose 3 books from 9, right? So this is a combination where the order that you picked the books didn't matter, right? All that matters is you had 9 books and you picked 3 without replacement. Okay, so that's going to be the denominator, the number of different ways that could have happened. Okay, so in the numerator, we're going to want the number of different ways that we could pick 1 dictionary. Okay, so we have 1 dictionary and you are picking 1. Choose 1, right? That's kind of, you don't need to write that. That's just 1, right? 1 choose 1 is 1. All right, then we're going to need to multiply that by the number of ways that you could have chosen. So remember, that's just 1 book. In the numerator, you need to explain what happened to all the books, right? So there's 2 more books that got selected. They were selected from these 8 other books, right? So you have 8, choose 2. These is the 5 novels and the 3 books of poem. All right, so if I calculate this, so this is 8 choose 2. I'm not choosing a certain number of novels and a certain number of book of poems, just kind of combining them there into this 8 other books, right? Because it doesn't say dictionary selected and 1 book of poem is selected. It doesn't say anything about the number of book of poems or the number of novels, right? All right, so this comes out to be 28 divided by 84. Right, so that's 1/3, but you're not going to simplify that here for the sake of time, okay? So on your exam, you will want to simplify fractions, though. All right, so let's go ahead and do the next one. So we have 2 novels. So the probability of selecting 2 novels and 1 book of poems. So 1 book of poems. All right, so now denominator is still the same. 9 choose 3. So 2 novels. Okay, so let's pick that first. So we have 5 novels and we're choosing 2. Okay? And 1 book of poems. Well, there's 3 book of poems and we're choosing 1. Right, you could write here that you have 1 dictionary and you're choosing 0, right? That's kind of not necessary because what's 1 choose 0? It's just 1. So, this basically times 1. So that doesn't really matter. Oops, I forgot the parentheses there. Okay, so what does matter here is that you have 3 books being selected in both the numerator and the denominator, right? So you see there's 2 books and then there's 1 book and there's 3 books total being selected, okay? So you should go ahead and simplify that. For the sake of time, I'm not going to right here. All right, so let's go on to another type of problem. This is the table. Now, there will be a problem on the test with a table, so make sure you definitely know how to solve these type of problems where you have some sort of table. You're going to want to know how to calculate lots of different probabilities given in a table like this. Okay, so let's go ahead and do A and B, and then actually I'm going to add on a few more different type of problems that you might want to be able to solve when you look at this. Okay, so here we have a study for the relationship of hypertension and smoking habits, and so here's the data. Okay, so H is hypertension, NH is non-hypertension. All right, so for part A, it says find the probability that a person experienced hypertension. So we want to find the probability of H given that they're a heavy smoker. I'm going to use HS for heavy smoker. Okay, so if it's given that they're a heavy smoker, it's basically like instead of having 180 individuals in our population, we only have the heavy smokers in our population because it was given that they are a heavy smoker. So that will be my denominator, 49, right? That's the total number of heavy smokers. Okay, so they are definitely part of this group, so the denominator just becomes 49. Now, how many of those of the 49 are hypertensive? 30 out of the 49. Okay, let's go ahead and go on to part B. So what's the probability that you are a non-smoker? So non-smoker, I'll use NS, given that they experience no hypertension. Person experiencing no hypertension. Alright, so let's see. So now, let me change colors actually. So we are given that we do not have any hypertension. So we are definitely part of this group. Okay, if you add up 48, 26, 19, let's see, I think you get 93. Alright, so what's the probability of being a non-smoker? If you definitely belong to this group I've circled in red, well, there's 48 out of those 93 that are non-smokers. Okay? Now I'm going to add a few more different types of problems that you should be able to answer looking at this 2x2 table. Another type of problem you should be able to answer is, well, what's the probability of being non-hypertensive? What's the probability of being non-hypertensive? So this is not a conditional probability, right? It's just asking you what's the probability of not being hypertensive. Well, we have 180 people in this study. I should have used C instead of B. We have 180 people in this study, so that will be the denominator. And how many of those are non-hypertensive? Well, I can add up these guys. It adds up to 93. Okay? So let's do another one. What about the probability of being a heavy smoker? Well, let's see. There's 30 plus 19. There's 49 heavy smokers out of 180 in the population. Okay, let's add one more. What about the probability of being not being a heavy smoker, right? Complement. So if we have heavy smoker, we can just do 1 minus that. Alright. What about the probability of being non-hypertensive and non-hypertensive and a non-smoker. So non-hypertensive and a non-smoker. Well, how many people meet that criteria? Non-hypertensive and non-smoker. Well, it looks like there's 48 that meet that criteria out of 180. So there'd be 48 divided by 180. Okay. Let me change my color. So what about calculating the probability of being, let me see, non-hypertensive well, let's change it to non-hypertensive or a non-smoker. How would you solve that? So that means you can be either or, and you're part of this group, right? So these guys meet one criteria of being a non-hypertensive. These guys meet the other criteria of being non-smokers, right? So what I've circled in green, those all meet the criteria. So I could add 21 plus 48 plus 26 plus 19. Or I could use the equation which says that this is equal to the probability of being a non-smoker plus the probability of being, non-hypertensive plus the probability of being a non-smoker minus the probability of being a non-hypertensive and non-smoker, right? You remember this is the addition rule, okay? So you could use this and you'd get, let's see, calculated all these other ones. So 93 over 180 plus 49. Nope. What is non-smoker? I don't think we calculated it yet. How many non-smokers do we have? 21 plus 48, so that's 69. So we have 69 of those guys. And then subtract off 48 over 180, right? What's going on here with this subtraction? Notice that, so this right here is 93 in this direction. This is 69 in this direction. So that 48 got added in twice. I added this way and I added this way. So that 48 got added in twice, which is why we subtracted off once, right? So that's why this addition rule works. So you can go ahead and calculate this and figure out that probability. All right. So you should feel really comfortable when you see a table, be able to answer a ton of different questions about probabilities based off that table. Let's go on to another type of problem. So the probability that you are home when a telemarketing representative calls is 0.4. So let me go and write that down. I'll use H for home. Okay, given that you are home, all right, so now it's been given that I'm home, so I'll go and write conditional on being home. The probability that goods will be brought home from the company is 0.3. All right, so I'll write G for goods is 0.3. I guess it's the probability that they'll make a sale, right? So find the probability that you are home and goods are brought from the company. So we want to find the probability of being home and goods are brought from the company. Now, do you guys remember this is going to be something related to the multiplication property. So remember the multiplication property was probability of A and B equals the probability of A happening times the probability of B happening, given that A already happened. Okay, so we're going to go ahead and use that here. So this will be equal to the probability of H happening times the probability of G happening, given H already happened. So this is 0.4 times 0.3, which is 0.12. All right, let's do another problem. So suppose that 4 inspectors are at a chocolate factory, are supposed to stamp the expiration date on each package of chocolate at the end of the assembly line. Okay, so John, who stamps 20% of the packages, fails to stamp the expiration date once every 200 packages. All right, so first let's write down a few things we just learned there. The probability that John does the stamp is 0.2. Okay, and given that John did it, the probability that he fails to make the stamp is 1 out of 200. Okay, so then next it says Tom, who does 60% of packages, so Tom does 60%, so 0.6, fails to stamp the expiration date 1 in every 100 package. Okay, so the probability that there's no stamp given Tom did it is 1 out of 100. Okay, lastly, not lastly, there's 2 more people. So then we have Jeff, who stamps 15% of the packages. Okay, so then we have Jeff, who does 0.15. The probability that he fails to stamp is Jeff fails to stamp the expiration date once in every 90 package. So if it was Jeff who did it, he failed. Oh shoot, I got 2 J's. I'll do JF for Jeff. Alright, and then Pat, who stamps 5% of the packages. Alright, so then we have Pat. Pat does 0.05. Fails to stamp the expiration date once every 200 packages. Okay, so Pat makes a mistake once every 200. If a customer complains that her package of chocolate does not show the expiration date, all right, what is the probability it was inspected by John? All right, so this is what we want to know. We want to know the probability that it was inspected by John, given that it had failed, right? So it did not have the expiration date on it. We want to know what the probability of it being inspected by John was. So let's see here. We're going to need to use Bayes' theorem for this one, right? So whenever you find yourself listing out a long number of conditional probabilities like this, you're definitely going to be using Bayes' theorem. Now, first thing, how to calculate conditional probability like this. This is Jeff and that there was a fail divided by the probability that there was a fail, right? And so Bayes' theorem says that this numerator, right, and actually just using the multiplication property that we just discussed, this is the same thing as being failed given it was Jeff times the probability that it was Jeff. All right, that's the multiplication property that we just discussed. So that's the numerator. Now, probability of failing. So using Bayes' theorem and also using what we know. So we have this probability of failing. This is the same thing as probability of failing and it was Jeff. Just a few ways you could fail, right? You could fail because Jeff did it. You could fail because Tom did it. You could fail because not Jeff, but John. So this would be Jeff. Jeff and you fail. Or you could fail because Pat did it. So Pat and you fail. Alright, so then we'd want to basically use the multiplication rule for all of these guys down in the denominator right here. Okay, so fail given Jeff, not Jeff, John, right? It's supposed to be the probability that John, John, times the probability that John did it, okay? Then each of these can be broken down by the multiplication rule. So this first one, this is the same thing that you see in there. Okay, and then you add that to the probability that you fail given Tom did it times the probability that Tom did it. You add that to the probability that you fail given Jeff did it times the probability that Jeff did it. And you add that to the probability that you fail given Pat did it times the probability that Pat did it. Right? This is the Bayes' theorem. You see how I just kind of derived it. You do have a formula sheet. This is like the only formula basically that's on that formula sheet. So you could look at it there. Once you have all this information though, you're basically ready to go ahead and plug it in. So I have probability that Jeff not Jeff, I keep on mixing up the J's. Up top here, probability of failing, given that John is the one who stamped it. So 1 out of 20 times John made a mistake, times the probability that it was John, not 20, but 200. 1 out of 200, John made a mistake, times the probability that it was John. John did 20%, so 0.2. Okay? Divide that by fail, given it was John, times 0.2. Then we go on to Tom. Tom made a mistake 1 out of 100 times 0.6 plus. Then we have Jeff. So Jeff made a mistake 1 out of 90 times 0.15 plus Pat. Pat made a mistake 1 out of 200 times 0.05. Okay, you can calculate this out. So for the sake of time, I'll leave that to you. Okay, so go ahead and simplify this. All right. Let's go ahead. So that's basically the stuff that you need to be concerned about in Module 3. Okay, so now moving on to Module 4 topics. Module 4, you want to be able to look at a PDF, right? And then determine some probabilities based off of that PDF, and then also construct CDFs based off of PDFs, right? Probability distribution functions. So let's go ahead and do this example. Okay, so here we have the total number of hours measured in 100 hours that the family runs a vacuum cleaner over a 1-year period is a continuous random variable x that has this density function, PDF. So find the probability that over a 1-year period, a family runs their vacuum cleaner 120 hours, less than 120 hours. Okay, so let's start with A. So they're asking the probability that x is less than, well, not 120 because x is measured in hundreds. So do 120 divided by 100. So that'd be 1.2. Right, so we want to find this probability. Okay, so for all continuous or random variables, to calculate a probability like this, we would need to do an integral. Okay, so we'll do the integral over where x is going to be in this probability. So it'll go from negative infinity all the way up into 1.2. All right, and then you'll do that you'll integrate f of x dx. Now, you have to be careful about what's going on here. From negative infinity all the way until we get to 0, this function is just 0. The integral of 0 is 0, right? So I don't need to worry about when x is less than 0. Once we get to 0, until we get to 1, this function takes the value of x. Okay? Then, from 1 until I get to 1.2, this function takes the value of 2 minus x dx, 2 minus x. So I'll need to integrate this piecewise, right? So you have to be careful about your bounds in your function to make sure that you're integrating over the appropriate space, right? Okay, so let's go ahead and do this integration. So let's see, this is 1/2 x squared, evaluated from 0 to 1. And this is 2x minus 1/2 x squared, evaluated from 1 to 1.2. Okay, so go ahead and plug in those bounds. We have 1/2, right? If you plug in 1, just get 1/2. If you plug in 0, so minus 0, so I don't need to write that. Then we have, over here, we have 2 times 1.2 minus 1/2 times 1.2 squared minus, okay, so I'm going to want parentheses. So this minus 2 times 1 plus 1/2, plugging in 1 right now, so 1/2 times 1 is just 1/2, okay. And so I want to go ahead and simplify this. Okay, I'll leave that as an exercise for you to do. I noticed I just wrote plus 1/2. That should have been a minus 1/2 because that's a minus there. All right. So you should go ahead and simplify this on the exam. All right. For part B, I'm just going to set this up. So the probability that x is between 50 and 100, so that'd be between 0.5 and 1, right? Because x is in hundredths of hours, so you need to divide what you see there by 100. All right, so in general, this would just be from 0.5 to 1 f of x dx, right? This is how you calculate probabilities for continuous random variables. But now I need to think about, okay, well, what is f of x? So I need to go back to what is my function. So let's see, 0.5 to 1, that's all going to be here in this first interval. So I'm going to be able to actually just calculate it right here. So this f of x is only going to be x. Okay? So when x is between 0.5 and 1, f of x is always just x. So I'd integrate this and solve this. Now, one thing you should be careful about when you're calculating probabilities, if you ever integrate and solve and get an answer that's more than 1 or less than 0, well, you know you made a mistake, right? Because probabilities are always numbers between 0 and 1, right? So make sure you're checking that. I'm going to add one more piece to this question. Let us calculate a CDF. Calculate the CDF of this. All right? So how would we go about in calculating a CDF? Let me go ahead and write that here. Find the CDF. All right? So as I said in the review from Module 4, you need to be able to find probabilities, but you also need to go from a PDF to a CDF. All right? So when you're calculating a CDF, we're going to want to consider all the different possible ranges. We use the t instead of x a lot of times when we're doing CDFs, just so that it doesn't get confusing with too many x's. So we want to consider all possible range of t. Okay? So I'll start with t less than 0. All right? When t is less than 0, what's the probability of remember, what is a CDF? So f of t is equal to the probability that x is less than t. Now, when t is less than 0, what's this probability going to be? It's just going to be 0 because f is 0 when x is less than 0, right? All right, so then let's go on to another interval. So now let's say, what if t is less than 2, right? Isn't that the upper bound of the first? No, the first one is 1, sorry. T is less than 1. So what is f of x then? So the probability that x is less than t. No, t is less than 1. So this would be the integral from -infinity until we get to whatever value t is of f of x. Right? So t is less than 1. So since t is less than 1, I do not have to concern myself with the second part down here, right? I do not have to concern myself for what if t is between 1 and 2, or x is between 1 and 2, because right now I'm restricting myself to t is less than 1. So I'm only in this piece right here. Okay? So this would be 0 to t x dx. Now, why did I go from -infinity and then now I'm saying 0? Well, because if I integrate from -infinity to 0, it's just integrating 0 because the function just takes the value of 0. So I don't need to write that. All right, so this equals 1/2 x squared evaluated from 0 to t, which is 1/2 t squared. Okay, so now let me do another last interval, less than 2. All right, so I should have said less than or equal to 0 or equal to 1, right? So you want to make sure you bound your t, right? So that if I said just less than 1, then it could have been -1, right? Which would put it in this interval up here. So I need to make sure my t's are bounded, right? Okay, so sorry. So this should be, it's more than 1, but less than 2, right? Okay. So let's see. If it's more than 1, but less than 2, what is my f? What is my CDF? Okay, so this is by definition what a CDF is. So from -infinity to t, f of x. Alright, so this is just definition here. Now, thinking about what my f of x is. Now t is definitely going to be more than 1, right? More than or equal to 1. So if I go up here, I'm going to need to get all the way from here to there, right? Definitely going to be where f of x is going to be 2 minus x. So I'll need to, first thing I'll need to do is integrate from 0 to 1, right? So -infinity to 0, that's just 0. And then 0 to 1 of x dx. And then I'll need to consider from 1 to whatever value t is of 2 minus x dx. Alright, so I'll go ahead and integrate this. 1/2 x squared plus 2x minus 1/2 x squared. Evaluated from 1 to t. Sorry, this part is evaluated from 0 to 1. Okay, so you would go ahead and simplify that. And we get 1/2, that's the first piece, plus 2t minus 1/2 t squared. Okay, minus, that's me plugging in t. Now I need to plug in 1. 2 minus 1/2, that's in parentheses. Okay, what's 2 minus 1/2? It's 3/2. Okay, so it's minus 3/2. So it looks like, so we have that positive 1/2 there. So let me go ahead and simplify this a little bit more. So this would be 2t minus 1/2 t squared and minus, so that would be minus 1, right? -3/2 plus 1/2. Yep, okay. All right, so let's see, that works. So last interval I need to consider is what if it's more than, what if t is more than 2, greater than or equal to 2. All right, so in that case, I would be integrating, so this is the f of t in that case, would be the probability that x is less than t, which would be the integral from -infinity to whatever t is, f of x dx. So I'd go from -infinity to 0, and that's just 0. So then I start from 0 to 1, x dx. And then I would be integrating all the way past 2, right? So 1 to 2 of, what is it, 2 minus x dx. And then anything above 2 would also be 0. So from 2 to infinity, the integral of 0, right? Because the function value is 0 outside of 1 to 2, or 0 to 2. Right? So it's 0 elsewhere, including above 2, right? All right, if you integrate that, to save time, I'm going to go ahead and let you guys know it should equal 1, right? That's basically a total integral over a PDF. Should always equal 1. If it doesn't, then you made a mistake, right? So go ahead and check that it does equal 1. All right, I'm not done. I need to write this very formally and nice, right? So we write this using a piecewise function. So your answer should be a nice big piecewise function. Okay, so you're going to start with considering t less than 0, then 0 to 1, then 1 to 2, then more than 2. Okay, so then fill it in with the information that we just found. So let's see, first one is 0, right? Less than 0, 0. Next one is 1/2 t squared, so let me go and write that down. So here it's 0, then it's 1/2 t squared. Okay, this one, I need to memorize it, so it'd be 2t minus 1/2 t squared minus 1. Minus 1/2 t squared minus 1. Okay, and then last one, it was 1. Okay, and this would be your CDF function. All right, let's do one more example. This time x is discrete. All right, so instead of integrals, we'll be doing sums. Right, so discrete, it's a little easier, I think. All right, so let me start by asking a few probability questions, because it's just starting by asking a cumulative distribution function. You want to be able to answer probability questions and CDF type questions, okay? So we say, well, what's the probability that x is at least 1? Find the probability that x is at least 1. Okay, so given this probability distribution function, the way you read this is x equals 0. That's a probability x equals 0. So x equals 1, it's the probability x equals 1, right? Okay, so the probability that x is at least 1 means that it's 1 or greater, right? 1 or more. So I could do that a lot easier by doing 1 using the complement, the probability that x equals 0, right? Because the total probability, if you add these all up, should equal 1. So 1 minus 0.14. Right? So you should be able to answer questions. Well, what's the probability that x equals 2? Right? That would be easy. What's the probability x equals 2? Well, you just look at the table. It's 0.16. Okay? So you add things up to find these type of probabilities. What's the probability? My stylus. Okay. What's the probability that x is between 1 and 4? Okay? So notice this doesn't include 1, right? But this includes 4. So you would add up these guys, 2, 3, and 4. So 0.16 plus 0.05 plus 0.01. Right? So it's adding rather than integrating for discrete random variables. Okay. So now let's say we're trying to construct the the CDF, the cumulative distribution function. How would we do that? Okay. I can do this by doing sums. All right, so let me go ahead and move my screen over a little bit. So starting with x less than 0, not x, but t. T less than 0. Well, if t is less than 0, well, the probability of x being less than 0 is 0. Okay, now let's say t is between 0 and 1. Well, between 0 and 1, but strictly less than 1, right? So if it's strictly less than 1, that means it's got to only be 0, so it says 0.14. Alright, so now let's say what's the probability that x is less than t, including 1. Right? So remember, what is a PDF? This is the probability that x is less than t. Right? So what's the probability that x is less than t when t is any number between 1 and 2, including 1? So basically it's less than 1. So I'd add up 0.141 plus 0.36 or 37. Okay, then between 2 and 3. You just keep on adding, right? So now x could be, or t could be 2, so add in 0.16. Okay, then 3 to 4, and finally greater than or equal to 4, right? So here, go ahead and add all these up. My stylus must have lost its connection because it's starting to get really shoddy. Okay, for the last one though, if you add them all up, what number should you get? 1, right? So the last one should equal 1. If you didn't get 1 for the last one, then you made a mistake, right? So on the exam, you wouldn't leave it like this. You would go ahead and do these sums and add them up. All right? All right, so good luck as you're studying for your exam. If you have any questions, any more problems that you would like to see me do, more than welcome to post them on the discussion board, and I would love to be responding to you guys and talking to you guys via that forum.